Hello, I'm Jason Pierce. I'm a professor of business management at the University of North Carolina at Greensboro. I'm posting this video in response to student requests for clarification on the phenomenon of regression to the mean. This is a topic that comes up in our course on managerial decision making, and one that's been discussed for many years by statisticians. I was hoping to point my students to a YouTube video already posted with some explanation of how this works. And what I found instead were a number of discussions that draw out the practical implications of regression to the mean while glossing over some of the technical specifics that we need to grasp to fully understand how regression to the mean works. So the purpose of this video is to provide just a simple explanation with a simple example that you can work with at home using this video, using this spreadsheet that you see on the video. I'll post the spreadsheet so you can work with the numbers and tweak them and play with them at home on your own to get a full idea how regression to the mean works in reality. And again, using a simple example of human height. Now, human height is one that will come up in the other videos. You're welcome to look at those, and then we'll get into that topic more details. But what happens is, if you watch those videos, and just like happened to me as a student when my professor brought up height as something subject to regression to the mean, left me a bit confused because it sounded like taller people would have shorter children and shorter people would have taller children, which is genetically not exactly how things work. So in this case, we're going to forget that for now. There's a reason that has to do with nutrition. That happened when that was first observed. But in modern times, with nutrition being more constant as far as quality and quantity, it's not as much of an issue. But in our reality, we still experience regression to the mean when it comes to height when we just run into people. So today's example that you see on the spreadsheet is just based on an imaginary population of 10 people with their heights listed. Now, there's a couple of principles we need to understand to appreciate regression to the mean and to get it. The first one is that every population or set of observations has a true mean. Now, we may or may not know that mean, or it might not even be feasible to know the mean, like the number of hairs that all of us have on our heads and the whole population, the whole world. It's really not feasible to go around counting those, but there is an actual mean. It is a true number, and it does exist. And it, of course, will change over time, if not constantly. So in this case, we want to simplify things. We have a population of 10. And again, this would also apply to just a set of any observations, be it of our own heart rate, our own even body weight, our own cholesterol levels, things like that, as well as populations that we look at heights, weights, income, GPA, if you're a student, and so forth. Now, in our population, our example, we have 10 people, number 1 through 10, with their heights, which range from 5 feet, this is in inches, of course, to keep it more straightforward, all the way up to 6'4". Now, these are typical heights that I've seen in our campus, in my classes, and all of us, most of us, I should say, fall along these. I've had a few outliers that are somewhat below or above this range. Now, when we look at these heights, we can simply compute the mean, which is, as I designed it to come out, roughly to 5'8", which is, I understand, the average height of adults in the United States. So that will be our true mean for this population of 10 people, which is approximately the mean of the population of our society. Now, when we look at that, we also know, in addition to being true mean, that each observation will be either below, equal to, or above the mean. Now, the number of people that are equal to the mean, or observations equal to the mean, will vary depending on the variance. And in this case, I eliminated any of those being equal to the mean to illustrate the point of regression to the mean more clearly. But of course, that can happen. Now, in this case, I have a little test cell that I can use here to show that some of these are below and some are above the mean, which has to happen, of course. And in this case, we have an equal number above and below. And that's also to keep things simple. Of course, in some situations, when we have skewed distributions, that will not be the case. But for our purposes, this is what we get. Now, to understand how regression to the mean works, we have to appreciate that when we make observations, we usually make them one at a time, and we eliminate those from the set of what remains to be observed. So if we look at our heights, our people, and I did this before by random selection that worked out using function Excel. I'll show how that works in a moment. I was able to get the following individuals came up to be included in a subset, 3, 5, and 10. Okay, oops. So heights for those individuals are 73, 76, and 75 inches. Now this initial subset, so imagine these are people at a gathering, in a meeting or a party, and there's 10 people there, you walk in and you go around meeting different people, and these are the first 3 people you meet. And suppose you're studying height, and you'd say, wow, okay, well, the first 3 people I met were 73, 76, 75 inches. So that gives me an average of 74.66, or essentially 2 2/3 inches. All right, that's quite tall. And so you might note that and say, well, is this population a tall population? Well, we also know that each of these is above the mean. Right, so we calculate this, we'll see that out of our 3 people, the first 3 people met, all 3 are above the true mean. Now this creates a situation where we can start to see how regression happens. And this is just one way to see how it happens. Well, these are observed, and so who's left to be observed? Well, it's the rest of the group. So if we copy them over and remove the ones that we already observed, we'll see something change. So we just delete 3, 5, 10. And what we'll notice is a couple things. One, now what remains, who remains to be met and measured, we have 2 that are above the mean and 5 that are below. What this tells us is that the next person that we meet, it's 2.5 times more likely, 5-to-2 ratio, 2.5 times more likely that the next person we meet will be below the mean. Okay, so this is, when you watch those other videos, if you watch them talk about that tendency for the next observation, the next experience to be on the other side of the mean, that's how that happens. Now, I want to emphasize this is a tendency because, of course, in this set, we still have 2 people, number 4 and number 9, who are above the mean. And so it's still possible those will be the next 2 people you meet. But that also sets us up to clearly show how how regression mean happens after that. If those were to the 2 next people, the next 5 wouldn't necessarily have to be below the mean. And if we were to do a running mean, from there, we'll see things change. So let's just do that for sake of argument. Let's just say the next 2 people were actually 4 and 9. So if you put them here, right? Even then, even though number 4 is above the mean, the running mean starts to come down. This is the regression already started. Even though that person's above, their mean starts to come down. So again, I'll undo that. So you can see it, that's the running mean with the first 3. We add the 4th person, and boom, it comes down a bit. And we'll see that will happen again, even though the next person is taller than the mean. So we go to number 9, oops, not there, here, 9 and 69, and boom, it comes down again. So this is the tendency to regress for our running mean here to regress to our true mean, which is here, right? Now, of course, as we add the next people that we've excluded, so when we can pick anybody at random if we wanted to, and let's do that. In fact, I'll show you how we could do that. This cell here is a random number generator. I just blacked it out so you can see what's going on. But this one says 4, which we've already picked. So 4 is gone. So let's look at something else. Let's do it just to put something in there. It says to give us 7. All right, so we'll put number 7 in, randomly chosen from what remains. 7 is 63. and boom, the mean comes down more and more. As you can see, as we keep going, this will eventually return or regress to the true mean. Okay. Now, this is a bit of a contrived example, and we could use this function here that I made. And if you want to see how to make random numbers, I'm sure there's plenty of YouTube videos on that. And there's another one I'll show you here that there definitely is a YouTube video for this one. So we could repeat this exercise using randomly selected. You could just, every time you change a value here, you say, okay, it says to pick 8. So I'll pick 8, which is number 8, 65. All right, and I gotta copy this over again. All right, and then it says the next one is 6. All right, oops, 6 and 64. Copy these down. All right, and then 5. All right, and so now we'll see as we watch our running mean, it will have a tendency to go from one side and then to tend back towards the mean. And if it goes past the mean, it will tend to come back. It will keep going. It will go past it and return to it each time. So that's how regression to the mean works. There's another function here. I can show you one last little example. So I'm going to black this out again to avoid distraction. And show you this one is if you wanted to make a subset and make your own random subset, you can use this cell, these cells, right? And this would say, instead of starting with the 3 tallest, you could start with these 3, 3, 5, and 6. Okay, and you can do the same exercise over again. If we keep running this, what we'll see is, and what this function does is it tells us we're going to try to pick on a 1/3 chance that any of these will be included in our subset. So we're picking 1/3 of the population, and we just say we don't know, we're just doing it at random with a 1/3 chance. We can keep running this, and what we'd expect with 1/3 of 10 is that there were 3 1/3 people would be included. And that's what we get here. We get 3, we do it again, we get 4. So between 3 and 4 is expected. If we keep doing this, eventually, so there's 4 again, we'll get high above and below. So right now we've got 2, right? So if we start getting 2s and 1s, it's going to be a greater likelihood that we're going to get 5. So there's a 2, there's a 1. Oop, did not want to do that one. All right, 2 again. So there's a lot of low ones in a row here, right? Eventually, if we keep doing this, and we keep track of it, this is quite a run of low ones, which is possible. It's anything. That's the other thing was probability statistics. It's always possible. So when we understand regression to the mean, and now here it starts. We have 6 here. 3 again. All right. It's a tendency. It's not a truth or a fact. It's not a necessity. And you can play with that and track that on your own and run these numbers and watch your true mean. If you keep messing with this and you watch your running mean, then you'll see the tendency for this number to regress to this number. Now it's going to vary back and forth, and that's why I teach this as very useful through stock trading, because that's what stock prices do. The true value of a stock is as a mean, is an implied mean. That's a more complex topic, but I'm not going to get in that right now. But the principle here is to understand that the numbers, as we make more observations, will tend to return to the true mean. I hope this is helpful. Thanks for watching.